So, a 74 kilogram person is standing in an elevator which is accelerating upwards at 1.5 meters per second squared. Calculate the weight and the apparent weight of the person. Use G equals 9.8. All right, so the first bit should be easy. Finding the weight. Weight, remember, is just Fg. So what are they? 74 times 9.8. Should be nice and straightforward. Uh, 725.2. Okay, so that's their normal weight. Now, we need to work out our normal force. Again, we need to remember that same thing we did all the way through circular motion. Okay? Remember this thing. F net is equal to Fn plus Fg. Now, where a couple of you went wrong in the last SAC and where we need to be very careful is getting our directions right. So F net, we are accelerating upwards, which means our net force is upwards. Okay, our gravitational force is downwards, and our normal force, the floor pushing us, that must be upwards as well. Okay, you need to get these directions right, otherwise it's really easy to mess up. So, if all of that is true, then we can rewrite this as F net, remember, is upwards, so let's call up positive. So Fn is also positive, then Fg is going to be negative. Okay, so we'll call down negative, Fg is down, so that is negative. So if we rearrange this again, we get Fn is equal to F net plus Fg. Okay, I've just added Fg to both sides. Now we know what Fg is, so let's get F net. Any idea how we get F net? Oh, I think I heard someone say MA. Good. Okay, we know the mass of the person and we know the acceleration of the person. They're moving upwards at 1.5 meters per second squared. So their mass is 74. Their acceleration is 1.5.
111.
Thank you very much. 111. And so plugging those numbers back into our equation down here, that one, so we get Fn is equal to 725.2 plus 111, which is equal to, what's that, 836.2 newtons. So their actual weight is 725, but their apparent weight is 836. So obviously they are going to feel heavier. Okay, they have a heavier than, you know, their usual weight. Their normal force is greater than usual, and so they will feel heavier. And that's exactly what we were talking about on the previous slide. They're accelerating upwards, you sort of get pushed into the ground a little bit, and so you would feel heavier than normal. Okay? The easiest way to stuff this up is to get these directions round the wrong way. Okay? Always draw a diagram for an apparent weight question, and make sure you've got your arrows in the right directions, and make sure, most of you are pretty good at that, arrows in the right directions, but then you forget this bit. Okay? Make sure you remember that those directions correspond to positive and negative. Okay? That's the easiest way to mess these up. The maths in them shouldn't be too difficult, as long as you get those directions correct. All right, any questions? Okay, try the next one.